Hi, my name is Oktay. Welcome to today's video about the Hubble Space Telescope and the great science it has given us. The telescope was named after Edwin Hubble. He was an American astronomer, and his measurements of the redshift gave us a better understanding of the nature of the universe. For example, Andromeda Galaxy is another galaxy, not a part of the Milky Way, and that there's a redshift increase with distance, which means that the universe is expanding. The Hubble Space Telescope was launched in April 24th in 1990 in the Space Shuttle Discovery to Earth's orbit. This is a picture of a quadruple moon transit on Saturn. At the left, this is the tiny moon Enceladus. This is the moon Dione. Here above the equator, that's the moon Mimas. And that's the biggest moon of Saturn, that's Titan. And this is a shadow of this big moon Titan. This is a picture of the red Triangle Nebula, HT 44179, located at a distance of 2,300 light years. The red Triangle Nebula was discovered in 1973. It's a protoplanetary nebula from an aging binary star system at the center. This is a picture from Earth of the red Triangle Nebula, and it could be that the red color comes partly from hydrocarbons. This is a picture of the Whale Nebula, a supernova remnant of a massive star with 20 solar masses. Supernova happened 10,000 to 20,000 years ago. The Whale Nebula is at a distance of 2,400 light years and has a diameter of 130 light years, and it expands at a speed of 1.5 million kilometers per hour. This is a picture of the Spirograph Nebula IC418. It's a planetary nebula at 3,600 light years distance. Spirograph is a toy which allows you to make the circle structures. That's a perfect name for this nebula. Its diameter is 0.3 light years. At the center is a massive O-type star, HD 34194. And this is how the future of the Sun could look like in about 8 billion years. This is a simulation of the future of our Sun. The nuclear reaction rate at the center, at the core of the Sun, will increase over time. The Sun will grow and eventually become a white dwarf. A picture of the Lobster Nebula, NGC 6357. It's an emission nebula at a distance of 5,500 light years and a star formation region with a diameter of 400 light years. The Lobster Nebula contains at least 3 star clusters with massive stars. This is a composite image of Chandra and other telescopes, and this region is called the H2 region because it contains ionized hydrogen. This is a picture from Earth of the Cleopatra's Eye Nebula, NGC 1535. It was discovered by William Herschel in 1785. It is located at a distance of 5,500 to 7,500 light years. Diameter is 130 light years, and again there's a massive O-type star in the center. This is a picture of a Type 1a supernova remnant SNR B050967.5. Type A supernova comes from a binary system with at least one white dwarf. This structure is located in the large Magellanic cloud at a distance of 160,000 light years, has a diameter of 23 light years, and expands at a speed of 5,000 kilometers per second. This is an artist's impression of a Type 1a supernova. Here you can see the white dwarf with the accretion disk that takes matter away from the big star. And at some time the system becomes unstable and then there's a big explosion. This is a simulation of a Type 1a supernova. The material is attracted to the disk around the white dwarf, and once it becomes unstable, that's when the explosion happens. And you can see there are several explosions, and that's why you have this complex structure. This is a picture of the small Magellanic Cloud at a distance of 210,000 light years. It has a diameter of 18,900 light years. It's a dwarf galaxy with about 3 billion stars and a satellite galaxy of our Milky Way galaxy. There's a bridge between the small and the large Magellanic Cloud, and in this bridge there is a star formation. So this little galaxy experiences a gravitation not only from the Milky Way but also from its bigger neighbor galaxy, large Magellanic Cloud. That's why it has this irregular structure. This is a picture of the open cluster NGC 376, which is located in a small Magellanic Cloud. It has a mass of 3,400 solar masses, and open cluster means these stars are bound loosely. This is a picture of Messier 106 NGC 4258 from Earth, an intermediate spiral galaxy that's between barred and unbarred. Messier 106 is at a distance of 24 million light years, and it has several dwarf galaxy companions, one of which is the NGC 4248. That's this tiny galaxy here. And this is a picture from Hubble of the central region of Messier 106. You can see an extra pair of arms in blue. These arms are not made of stars, but for hot gas, which comes from the activity of the supermassive black hole in the center of this galaxy. This is NGC 3568. It's a spiral bar galaxy at a distance of 57 million light years. It's about half the size of our Milky Way galaxy. And in 2014, there was a supernova in this galaxy. Supernovas are important requirements for life because they not only produce the elements that are required for life, for example, calcium, zinc, iron, but they also distributed this material back into space so that new generations of stars and planets could form. This is galaxy NGC 1316. This is a picture of the Very Large Telescope located at the edge of the Fornax Cluster. This is the galaxy. And this is a picture from Hubble of this galaxy. It is a lenticular galaxy, which means it is an intermediate between a spiral galaxy and an elliptical galaxy. It's a spiral galaxy that is about to become an elliptical galaxy. These arms will slowly disappear. And this Fornax A galaxy is located at a distance of 62 million light years and has a diameter of 50,000 light years. And it is a radio galaxy. And its source is the active galactic nucleus with a supermassive black hole of 130 to 150 million solar masses. For comparison, the central black hole of the Milky Way has a mass of 4 million solar masses. And at this galaxy, there were 4 supernovas that were detected. This is a beautiful barred spiral galaxy, NGC 6217. A distance of 67 million light years with a diameter of 55,000 light years, so it's about half the size of the Milky Way. It's a starburst galaxy with H2 region in the center with high star formation rate. And in this galaxy in 2018 there was a type 2 supernova, which is an explosion of a massive star. This is a pair of galaxies, at the left NGC 2293 and at the right 2292. The bigger galaxy at the left is again a lenticular galaxy which is about to become an elliptical galaxy. And this pair is located at a distance of 100 million light years. It has a diameter of 160,000 light years. And these merging galaxies have a common ring. The orange color comes from old stars. There's another lenticular galaxy, NGC 7049, at a distance of 100 million light years. Diameter is 150,000 light years. And it contains just few globular clusters. And this is one of three galaxies which are called Indus Triplet, together with the other galaxies NGC 7029 and NGC 7041. This is NGC 6956. It's a barred spiral galaxy at 214 million light years distance. And there was again a type 1a supernova of exploding a white dwarf, and this explosion was used to calculate the distance of this galaxy. This is NGC 7038. It's an intermediate spiral galaxy between the barred and unbarred structure. It's at a distance of 220 million light years. It was discovered by John Herschel in 1834. And in 2010, there was again a supernova SN 2010 DX. This is a picture of from Earth of our own galaxy, the Milky Way. At the left, you can see this dark structure. That's the disk of the Milky Way. Inside the disk, there's a bright structure. That's the bulge of the Milky Way with a high concentration of stars. This is again a picture of the Hubble Ultra Deep Field, which shows you a distribution of the galaxies in the universe. This gives you an idea of the network structure of the universe. There are elements of the galaxies and galaxy clusters, and there are big empty spaces in between, which are called voids. And this is a computer simulation of the filament structure of the universe. And dark matter plays an important role in this structure. Without dark matter, the galaxies would not be able to keep the structure. The stars would fly away. And you can again see this filament structure with empty spaces in between. These are called voids. And that was today's video about Hubble Space Telescope images. Thank you for watching. Have a nice day. Bye-bye.